large fragments from a volcanic eruption can be deadly. But it's the small fragments, particles less than 2 millimeters across, that are actually more dangerous. This is number 6 on the list of volcanic hazards: ash. Volcanic ash isn't soft like wood or cigarette ash. It's hard and abrasive because it consists of silica and pulverized rock. Blown up into the skies, a cloud of ash is a particular danger for airplanes.
Flying into a volcanic ash cloud is like flying into a cloud of tiny little nails. That volcanic ash is ingested into the airplane engine. Silica, which has a melting point very similar to the temperature in the jet engines, actually melts in the jet engine, covering the components with a sticky substance.
Then, the melted ash is sucked through to cooler parts of the engine, where it solidifies and jams the works. The result? Flame out. Total engine failure. More than 100 planes have been caught in volcanic clouds. At least 7 suffered engine failure. And 3 planes experienced complete engine loss and faced the possibility of a fatal crash. In 1982, a 747 was surprised by a volcanic cloud 37,000 feet over Indonesia. All 4 engines failed. The jet fell 23,000 feet before the pilots could relight the ash-clogged engines, narrowly averting a watery grave for themselves and 248 terrified passengers.
Pilots should turn around and fly 180 degrees in the opposite direction of where they've come from to get away from that ash plume.
But ash is not only an airborne threat. It also stalks victims closer to the ground. People who run inside to escape being buried or suffocated by falling ash may be running into a death trap. Volcanic ash is dense. A 4-inch layer is enough to flatten many shelters. And when the ash is wet with rain, its deadly density increases.
If it's on your roof, the roofs will collapse, and if there are people taking shelter under these buildings, it's those collapsing roofs that really are the danger.
While ash is a danger from the air, volcanoes have another weapon that strikes from the sea. Volcanic hazard number 5, tsunamis. Volcanoes grow by piling up lava and tephra. But a rising mountain can become unstable, especially if hot acidic gases are percolating through the rocks. This leads to structural collapse of a face or flank of the volcano.
Collapses from the flanks of Hawaiian volcanoes are now recognized to be quite common, and it's a normal part of the volcanic life cycle for parts of the flanks to spall off and go into the ocean.
When you take large pieces of something like this and drop them into the ocean, it tends to make a splash. These splashes are tsunamis.
Not just flank collapses, but the shock from a giant eruption can also trigger tsunamis. In 1883, Krakatau in Indonesia generated waves as high as 120 feet.
The Krakatau eruption was the equivalent of about 200 megatons of TNT, or about 10,000 Hiroshima bombs.
The Krakatau tsunamis destroyed 295 coastal villages. In all, volcanic tsunamis have caused more than 50,000 deaths in recorded history. And everything's in place for the death toll to increase. The greatest danger may come from Hawaii's immense Mauna Loa, whose southwestern flank has collapsed more than once in the prehistoric past, creating mega tsunamis over 500 feet high.
And this is enormous. This is way bigger than any historical tsunami that we know of. The good news is the last one was over 125,000 years ago.
The bad news is that nothing on Earth could stop another mega tsunami from Mauna Loa from hitting the Big Island.
Almost certainly the tsunami would be devastating to Hawaii.
While flank collapses in coastal areas can cause tsunamis, volcanic collapses farther inland can trigger deadly mudslides called lahars. Lahar, the Indonesian word for mud flow, a particular danger on volcanoes high enough to be capped by snow, ice, or even glaciers. Volcano hazard number 4, lahars.
Basically, a lahar is a volcanic flash flood. Mud and ash and rocks mixed in. It starts to pick up all the material that it's flowing over, the rocks, the dirt, the trees. Lahars are pretty scary things.
The fatal effects of lahars were demonstrated in Colombia in 1985. The Nevado del Ruiz volcano, topped by a glacier, erupted after 140 years of quiet. Ash and gas flew 19 miles into the night sky. 2,000-degree heat melted more than 600 billion cubic feet of glacier ice, creating an unstoppable lahar that swept through the town of Armero, killing at least 23,000 people. Nevado del Ruiz was a wake-up call for geologists studying another volcano in the Cascade region of North America, Mount Rainier. Rainier looms over a populated area. Rainier also hunkers under a glacier.
We have 1 cubic mile of perennial snow and glacier ice on Mount Rainier. That's as much as on all the other Cascade volcanoes combined. The combination of hot eruptive products and snow and ice melting has potential for lahars.
Earth Sciences professor Pat Pringle has spent decades uncovering evidence of Rainier's history of gigantic lahars.
My guess is that this flow is probably within the last few thousands of years. We can actually see that this mass of sand was carrying some small pieces of the bank that it ripped up from places upstream. And this shows you that this was moving as a mass of material, probably 80% solid material with about 20% water. So, I mean, we kind of flowed in here almost like flowing concrete.
Rainier doesn't even have to erupt to cause a lahar. Almost 600 years ago, structural weakness on the western side led to a flank collapse that gathered material and momentum, sending a mudslide all the way to Puget Sound, 60 miles away. Today, the lava is building up, and the western wall is weak again.
We have earthquakes at Mount Rainier all the time, and depending on the size, our fear is that one day it will cause that structural collapse in the weakened zone.
Another collapse on Rainier would trigger another deadly lahar. This lahar would probably follow the same path as 600 years ago. But the former wilderness now contains tens of thousands of lives, homes and businesses, all at risk.
We're going down the Puyallup River Valley, and this is about the speed the mud flow would have been going when it was coming down here from Mount Rainier. You can imagine a wall of mud and rock 30 feet deep coming through this area. That's what it would have looked like. So it would have buried this whole valley from valley wall to valley wall, more than a mile across.
Nothing could stop the next great lahar from Mount Rainier. And nothing could defend the port of Tacoma.
The port of Tacoma is the 6th largest port in the world. And for us in Washington, it's really a gateway to Alaska and to Asia.
Pierce County Emergency Manager Jody Woodcock knows what a lahar from Mount Rainier could do to the port.